For the third example, I wanted one that compared two groups, and that's what this one does. It compares house prices, or really average house prices, between two California cities with pretty similar names, Eureka and Yreka, which allegedly comes from the word bakery spelled backwards. Here's the initial Zillow search results screen for Eureka. I did make the same adjustments I made for Kybers. I changed the listings to recently sold only, and then the home type is just houses, but look how many you get. You get 1,726. That would be a lot of work if you were going to retype that manually. So this is a situation where you probably don't want to do that. And like I said in the project instructions, when you have two groups, it's okay if you just use 25 of each if you end up taking a sample of a sample. But if you're going to take a sample of a sample, just make sure you include that in the write-up. So where you end up saying something like, we had 1,726 search results, but then we only used the most recent 25. And then I think you can do the same thing for Yreka as well. There are only 455 results, I suppose only in the context of comparing that number to 1,700, but that's still a lot if you were going to do it translating everything by hand into a spreadsheet. So again, if you just use the most recent 25, I think that's fine. Just make sure you include that in the write-up that that's what you did. As far as the inequality in the alternative hypothesis is concerned, this is the option that I would go with personally. I kind of knew where they were going in. I've never been to Eureka, but I know it's on the water. And I've never been to Yreka either, but I've been close to it. I've been to Mount Shasta before, and that's only maybe an hour away. So I kind of knew going in that Eureka was on the water, and I knew that Yreka was a little place on I-5 generally on the way up toward Oregon. So I think it's reasonable to think Eureka is probably going to be more expensive. As far as the other possible inequalities are concerned, there must be a way to justify a two-sided inequality. It's just not something that I'm seeing right away. However, the other one-sided inequality, anticipating that Yreka would have more expensive housing, that one's kind of hard to justify, I would think. I think if you're going to do a one-sided alternative, it's probably the one that I've got. And the way that I had it set up on the previous slide with the map, that's the way that I'm going to go through the rest of the hypothesis test. Writing out that alternative in words, so the one-sided one on this slide, which is how I'm going to handle the rest of the test, we'd be looking for enough evidence to conclude that the mean price of houses in Eureka is higher than the mean price of houses in Yreka. I stuck the two-sided one on there as well since I figured there probably is a way to justify using that, but I'm going to stick with the one-sided alternative going forward. Explaining where the sample data came from, for both cities, it's a Zillow search where I changed a couple of the filters to be recently sold only and then houses only, no condos or anything like that. And then for both of them, there were a lot of search results, so in each case I just used the most recent 25. If you use the Eureka minus Yreka order of subtraction, what you end up with for a p-value is the chance of obtaining a difference of sample means of at least $73,248.20, assuming that the two population means are the same. That would be the null hypothesis here, that mu1 equals mu2 or mu Eureka equals mu Yreka. I suppose if you use the other order of subtraction, everything's going to flip around, but if you use the other order, you get something kind of awkward looking here, so we'll stick with this order. This slide has a screenshot of the p-value on it, and you can also see where I got the cutoff of $73,248.20. Right under where it says original sample, right there, there it is. So I said, okay, there's the difference in sample means, so that's going to be my cutoff. And based on the way that I have the inequality facing in the alternative hypothesis and the order of subtraction that I used, this is going to be a right tail. And you end up with a p-value that's pretty small. That p-value is certainly less than 0.05, which means the null should be rejected. That means we have enough evidence or sufficient evidence to conclude what's in the alternative, which I suppose here is that the mean price of houses in Eureka is greater than the mean price of houses in Yreka. As far as reservations or limitations are concerned, that first one also applied to the Kybers example because the data were acquired the same way. It was done by searching Zillow. And not all houses that are for sale are going to be listed on Zillow. Generally, that's going to be the case. The other thing that's worth mentioning here is that for each city, we used a sample of a sample. It was the most recent 25 out of whatever came up. That was another thing that could factor in here that you could view as being sort of a limitation or maybe something that would cause you to have a reservation about the conclusion. For this example, the CSV file looks a little bit different because for each value, you also have to say what group or what sample that value goes in. So the first column is supposed to identify the group, and I just called the groups Eureka and Yreka. So for every row, basically what I did is I said, okay, in this city we have this value. And I just kind of cycled through all the Eureka ones first and then did all the Yreka ones. So really I have 25 Eureka entries followed by 25 Yreka entries. I figured it would also be worth pointing out why you have to set the CSV file up like that when you're doing a test for a difference in means. So if I go to test for a difference in means and I go to upload file and then Eureka and Yreka, I need to tell StatKey where the numbers are and then where the categories are, and here the categories are the two cities. So quantitative variable first, then categorical variable, and then OK. If you look at the original sample box that sorts them, it puts all the Yreka ones up here, all the Eureka ones down there, and where it has x1 bar minus x2 bar, whatever you put in first, that's what it considers to be sample number 1. So I had Eureka first, so the x1 bar is really the sample mean for Eureka, and the x2 bar is really the sample mean for Yreka, since I had that go second. But once you have the sample data in there, then you're just going to generate your 5,000 bootstrap samples, and then this is going to be a right tail bounded by 73,248.20, and there's the p-value.